Hi, my name is Shahadlek Habib. My student number 203721060. I will talk about self-organizing map for solving traveling salesman problem. The content of this presentation is introduction about the problem, definition of the problem, algorithm explanation, modifying the algorithm, the evaluation of the algorithm, and finally conclusion. Introduction of traveling salesman problem. Traveling salesman problem is one of the most famous problems in artificial intelligence. And the main question when we talk about this problem is, when I given a list of cities and the distance between each pair of the cities, what is the shortest possible route that visited each city exactly once and returned to the original city? The classical traveling salesman problem involves finding the shortest and cheapest path, that a salesman can take to visit and cities, where each city is visited once and only once, and the salesman must return to his starting point. This type of problem and its solution has application in other areas such as the scheduling of a production, maintenance, and the backups and deliveries, etc. When we define the traveling salesman problem, we can consider this example. In an city travel salesman problem, the salesman must not only visit each city once and only once, but a subset, a cluster of these cities must be visited contiguously. For example, in a particular problem, cities I, J, and K must be visited contiguously in one of the following order: IJK, IKJ, JIK, and continuing in this order to avoid any revision. There may be more than one cluster within a given problem. The order of visited within each cluster is not specified. If it were, the problem would simply break down into finding the optimal route among the cluster. The path through a cluster must be contiguously and only linked with the other cluster at the beginning and the end of the path. To explanation and modifying the algorithm. Firstly, must define the algorithm, that is a type of artificial neural network that is trained using unsupervised learning to produce a low-dimensional, typically two-dimensional, discretized representation of the input space of the training symbols, called a map, and is therefore a method to do dimensionality reduction. Self-organizing map is different from another artificial neural network because they apply competitive learning as opposite to error corrective learning, and because they use neighborhood function to preserve the topology properties of input space. The important concept to grasp using the network to solve the TCP is how to adjust the neighborhood function. If we define a circular array of neurons instead of a grid, each Each node will only be aware of the neuron in front of it and behind it. To put it another way, the similarity will only function is one dimension. With this small change, the self-organizing map will act like an elastic ring, coming closer to the cities while attempting to keep the perimeter as small as possible due to the neighborhood function. The modification to modifying the algorithm to ensure the convergence of it, we can include a learning rate to control the exploration of the algorithm. To obtain high exploration first and high exploration first after that in the execution, we must include decay in the both of the neighborhood function and the learning rate. Decaying the learning rate will ensure less aggressive displacement of the neuron around the model, and decaying the neighborhood will result in more moderate exploration of the local minimum of each part of the model. We can see this expression where rate is the learning rate at a given time, and G is the JSON function centered in a winner, and with the neighborhood this precision of H, and decay function consists of symbol multiplying the two given discounts for the learning rate and the neighborhood distance. Finally, all that is required to retrieve the root from the self-organizing map is to associate a city with its winner neuron. It traverses the ring starting from any point, and sort the cities according to the order in which their winner neuron appear in the ring. If many if many cities map to the same neuron, it is because of the self-organizing map didn't consider the order of the passing, such as city, due to lack of importance for the ultimate distance or insufficient precision. In this instance, any possible order for such cities can be evaluated. I used Python as a programming language to programming an algorithm that solving traveling salesman problem. When we wanted to evaluate any algorithm, a real example of the best area to evaluate it. So I will use several examples from real life countries and provide the best solution route for most of them by the following these metrics: execution time and the quality of the solution. Execution time invested by the technique to find the solution. Equality or quality of the solution as a percentage of the optimal route. The parameters used in the evaluate were discovered through parameterization of the approach is a population 8 times that of the cities involved in the crisis, discount rate of 0.9997, and initial learning rate 0.9. The number of cities in the initial neighborhood decay 0.9997. These parameters were applied to the following instance. Can see this figure have a real example for four countries: Qatar, Uruguay, Finland, and Italy. The implementation also stop the execution if some of the variables decays under the useful threshold. A uniform way of running the algorithm is tested, although the exact parameters can be found by each instance. The following table gather the evaluate results, where the average result of 5 executions in each of the instances. Here in this figure, we can see how time conception is proportional to the number of the city, because the difficulty of locating the nearest neuron in a city is proportional to population to traverse. In a wide number of cities, greater outcomes are attainable, but due to time constraints, they are usually cropped shorter. The results are seldom more than 13% longer than idle. In the other, shorter situation, it's fascinating to see how even though the challenge is more difficult in Uruguay because of the country topology, so a higher quality is achieved. The technique path may be seen in the graphical depiction of the execution. It begins as a elastic fast change ring, seeking to adapt to its shortest shape possible, and then begins to maintain its position to identify better local routes within of it. To do this, many neurons are added to the network and the parameters are degraded. Ensure that exploration coming first, followed by location exploration to refine the answer. Expect under particularly demanding situation for the TCP, the results are generally acceptable when we can observe how a suboptimal path cruising over 700 cities and determining in less than half a minute. Finally, conclusion. Briefly, we use the specific approach of a self-organizing map to find solution of the traveling salesman problem by making some simple change to find similarities. We were arranged cities with the shortest possible path and with appropriate results. Thanks for listening.